This video looks at the Solow growth model. In particular, we're going to evaluate the model, and in this class of models, our key metric in evaluation is whether they generate permanent GDP per capita growth. So our question is more output per person, and the permanent piece means it must be true in steady state. So we're going to be evaluating this in terms of whether or not it generates permanent steady state GDP per capita growth. Now, in this economy, we measure GDP per capita. It is GDP over N for the number of people, and we'll usually approximate that with GDP divided by the number of workers. The reason we can get away with that is because workers are generally a constant proportion of the population. This can be thought of as our labor participation rate. This is the percent working, so it's sort of like labor participation and employment rate. But whatever it is, if there's 100 people in the economy and 60% are working, then there's 60 people in the labor force. So the two are going to move together. So we generally use one of these as an alternative. In particular, we define this as little y. Okay? So we're constantly going to be coming back and asking, is the growth rate in steady state greater than 0? And that's sort of our key question and our key metric. Now, how do we go about evaluating that in this model? Let's start with the basic assumptions of the Solow growth model. In the basic model assumptions, we have one, that there is no population growth. Population here is N, and so we're going to say there is no population growth. We usually think of the population growing at a rate of N. By the way, this will imply that there's no labor force participation rate growth either. 2, we'll assume no technological growth either, that is A hat is 0. So when I want it to be something else, I'll let G be something else. But this is the growth rate of technology, this is the growth rate of population, both are 0. So there are a couple of steps in evaluating it. Step 1 is going to be to use the definition of steady state. The definition of steady state in these models is that the change in K is 0. That means the definition of K, little k, which is capital stock per worker, when we convert it to hats into growth rates, we get this. Little capital is growing at a rate of big capital minus labor. This by assumption, and I'm going to put this just to remind us of what's the assumption here. By assumption, by definition, this is 0 in steady state. So in steady state, this must be 0 too, because this is the growth rate. Don't forget, that's the definition of a growth rate. So if the change piece is 0, the whole thing is 0. So this is the definition of little capital. So when we convert it to growth rates, they must be 0. Now look, we assume 0 population growth, so that L has to be 0. This is growing at 0. So if K hat minus L hat is 0, that means K and L must be, K hat and L hat must equal each other, which means K hat is 0. Okay? what does this mean? This means if I were to draw L over time, we'd get a constant line. This being 0 also means if I were to draw capital over time, I would get a constant line. So if little k is just big K over L, both of those are constant. So my little capital, which is capital per worker, is also constant. Now, step 2 is to look at production. Production is the basic Cobb-Douglas in this economy. I want to convert this into hats to see what's happening to output in steady state. Now, output per worker in steady state, the growth rate is the growth rate of tech plus the growth rate of capital adjusted here. This is 0 by assumption, right? So this is 0 by assumption. That's 0. This is also 0 by assumption. Right? So this is also 0. So overall, this must be 0. Step 3 is our goal. And I should really circle that in red. This is our goal. What's happening to GDP per capita? We can get that from here. The definition of that is this. Or if you want, I could do it over N. When I convert this to growth rates, we know from right here that this one's 0. We know from here that this is 0. The whole thing is growing at 0, right? That was our conclusion. So that means these two are growing at the same rates. That one is 0. So this means, so if I were to draw a time path for y, it would look like this. I could do the same here, by the way. This is 0. We got that from here. This is 0 from the initial assumption, and so this has to be 0 too. So if y is constant, L is constant, then little y over L is also constant. The result is we get no permanent growth in actual GDP, and we get no growth in GDP per worker or per capita in the basic Solow model.